evening, ladies and gentlemen. Today on the Physics Report, we are going to be discussing the physics of dancing. We are also going to have a breakdancing exhibition, and we will be joined by our special guest, Dr. Wynn, to talk to us about physics in dancing and movement. But first, a look into the physics that makes dance and everyday movement possible.
Thank you, Antonio. Physics is a very intimidating science filled with symbols and characters, but once you understand what the symbols mean and what they do, physics is much easier. Don't freak out, these are just symbols. Angular velocity can be simply broken down to how fast, that's velocity, and the spin, that's the angular. Now rotational inertia, it is how much an object will resist spinning. Rotational inertia is found by multiplying the mass of the object by the square of the radius of the object. So, angular momentum. It's how difficult it is to change the rotational velocity of an object. To find the angular momentum, you would multiply the rotational inertia I by the rotational velocity or speed of the object. Now for probably the most visually intimidating concept, torque. Torque is the force that causes things to spin. The movement to spin something is more complicated to define, therefore the use of trigonometry. What this equation is stating is that torque is equal to the force times the distance from the turning radius, sine theta. Sine theta is a trigonometric function that deals with angles. Theta is your variable and is an angle measure. The vertex is the point of which the force is added, and the line is the direction the force is added. To solve for sine theta, you will need a calculator that has trigonometric functions. Here is a video of Antonio exerting a torque, and as a result, you can see his angular velocity will increase. Because Antonio's legs are extended, he has a high amount of rotational inertia. However, he is overcoming the inertia by exerting an even greater torque. What this equation states is that there is a change in angular momentum is equal to the torque to times the change in time. What this equation tells us is that the harder we push and the longer we push, the greater the change in angular momentum. So if by adding torque, we know that it will change the speed of a spinning object, but based on these equations, we know that there are other ways of changing velocity without adding torque. If our momentum remains constant, meaning we don't add or lose any torque, then the only way to change our momentum is to change our inertia. And based on the equation for inertia, the only way to accomplish this is to lose mass or shorten the radius. If you have ever spun yourself in a rolling chair and you notice how you slow down when you stick your feet out, this is because you have changed your rotational inertia. The movements in all kinds of dance are reliant on these basic physics principles. When a person is balancing, especially in breakdance, the smallest force or torque could knock them over. In order to maintain balance, they must keep their bodies steady over a center of gravity in order to prevent adding any additional force or torque, which as we learned turns into acceleration, which then turns into momentum, which leads the dancer to fall. In this clip, we can see Antonio has applied a great deal of torque and loses his balance, throwing his off his axis of rotation, in this case his arm, and he falls. In this bit, we see that Antonio was not able to maintain a center of gravity, nor an axis of rotation. As a result, gravity becomes the sole acting force on his body, and he falls. Adding torque is an integral part of dance and movement. Dancers are able to add torque by pushing off the ground at various distances to add more or less spin. Thanks to Newton's third law, we know that pushing off the ground will exert an equal and opposite force back on us, which gives us torque. If you remember the earlier discussion of increasing speed without adding torque, you can increase velocity by shortening the radius of your body. Dancers accomplish this by manipulating their bodies to increase and decrease their rotational inertia. However, this only applies in situations where friction is low, nearly non-existent, such as ballerinas and figure skaters. In this clip, Antonio is able to maintain an axis of rotation While his legs are in the air, he manipulates them to slow down and to speed up various parts of the move. When jumping in the air, it is impossible to add or take away torque. Therefore, L is constant. Like with turns, you must increase or decrease inertia to change velocity. Again, dancers accomplish this by manipulating their body position. Here we can see Antonio extending and retracting his legs in order to rotate around his axis of rotation the way he does. Physics is everywhere around us, and it is because of these principles that I have shown you dance is possible. And now back to Antonio Rodriguez with an interview with our special guest, Dr. Wen.
What is capoeira?
Capoeira is a martial art that originated in Central Africa.
How is momentum and acceleration important in capoeira?
Some of the more evasive movements, such as a au or a cartwheel, that's a circular movement that requires a tremendous amount of body control. To stop that movement mid-motion or to change direction mid-motion, if you identify that your opponent is trying to throw a strike at you and catch you while you're moving, transitioning from one to the next, you need to be able to control your body, decelerate it, change your momentum, and move into a different direction. And all of that requires a tremendous amount of body control and the application of different concepts of physics.
How is toric important in capoeira?
In a lot of the capoeira movements are circular. So like we mentioned earlier, the au or the cartwheel, in order to rotate the entire body from both feet to both hands, back to both feet again, it requires spinning around an axis, which would be the center of gravity or the center of your body or abdomen, and generating enough torque, utilizing the limbs to propel the body in that rotation. So in many of the movements, torque is used to generate the movement. Hava Jahai, which means stingray tail, it's a spinning kick movement. So essentially you're spinning around the axis of the base foot, and the strike is delivered with the extended leg. So the extended leg would be generating, rotating around that axis, generating torque. Depending on how much spin you put in, how much effort you put in that spin, more torque is generated, making a more powerful strike if you choose to actually land it on the opponent. So torque is utilized throughout a tremendous amount of capoeira movements.
Thank you, Dr. Wood.
And that'll do it for our show. I'm Steven.
And I'm Antonio.
Catch you next time on
The Physics Report.